I have a bit of a cold, so I may have trouble talking, but we'll see how it goes. Okay, so I am going to talk about R packages. And R packages is how you extend functionality of R. And there is a lot of packages. So you can find a lot of packages on RCran, and you can also make packages yourself. You can get packages from GitHub, many other places. So there's lots of packages, and that means that you can use R for a great many things. And it's always good to check if others have already done what you want to do. So you may not need to write something yourself. You may be able to find a package that does exactly what you want to. And you will find most of those on RCran, as I said. So what is an R package? That is a question we're going to look at here. And how do I find packages and versions available? And what if I need other packages? How do I get that? And what differences are there between HPC2N and UPPMAX and other systems, of course, in Sweden. But doing this, what we are doing here, you will learn how to check. So objective is to understand the basics of what an R package is and show how to check for R packages and how to install your own packages. So what is a package? Well, it's a folder and file structure that contains R code, maybe also other code like C, C++, whatever, and some other files that are relevant for the package, which often could be documentation or small vignettes or something. That will also often be licensing and configuration files. So here's a very simple example. And you can actually go and clone it from this place here, but you don't need to do that. We're just going to talk about it. But this is just a small example that does very little except saying hello. And if you looked at the structure, which you could, if you fetch it, there will be a description. There's a namespace. Then there's a directory called R, and under that is R code. There's a man file, and man files are documentation files. And then there's an example. So package states. What state can a package exist in? Well, it can just be source code and source files when it's in development form. And then you can have it in what is called bundled form. That means that it's compressed to one file. It's usually a tarball. That is what you just saw for the example file. And tar is a program that is used to cut a lot of files together and was originally used for tape storage. It's a very old package system. It's from early 70s, I think, if not earlier. And it's still used a lot. It's a way of gathering everything up in one file, and then usually it's compressed with gzip or something similar. And that is something you will find very often when you are fetching software or online. And when you do an R package and bundle it, you can ignore files that you put into .r_build_ignore. And then it could be in a binary, and that means that it's already bundled up and built for a specific architecture. So maybe it was for Windows or for Mac or for various flavors of Linux or whatever. This is generally how CRAN provides it. And CRAN is this place where you can find a huge number of R packages. And that is the easy and fast way of getting it. So if it's there, you should get it from there instead of compiling it and building it yourself. And then, of course, when that is done, it can be it is installed. That is when it's decompressed and located in your package library. We will talk more about this. And there is one last state that it could be in, and that is it's in memory. And that's when it has been loaded inside of R. So, and here is just an overview of what was said. And this line here should have been shifted down. So this is just a link to where this material was taken from. So package libraries. And you should note one more thing, which is the same as you probably noted when we talked about Python, that people will use library and package interchangeable. And that can be confusing. But you should, for instance, there's an example here that something could refer to dplyr as a library when it's actually a package. And well, there's nothing really to do about it. People are confusing it online, so it might, so just know what they're talking about. So what about our systems or other systems? You want to know where it looks for packages. Where are these libraries located? And to do that, an easy way of doing it is to simply start R. So let's go ahead and do that. And I'm going to do it here on UPPMAX. First, I will see, do I have anything loaded? I don't. So then I will load R. And on UPPMAX, you can load it directly. So I'm going to load R411. And then it gives you a message here, which is that they have most of the CRAN and bioconductor packages installed and available directly in the module. That's nice, very nice. So let's start R, and then we will give the command libpaths here. And I will now show you what it does. It shows you this path here on the system. And this is where you have these libraries installed. So let's quit R again. I will not save the workspace because I don't have a reason for doing that. And on HPC2N, I will just quickly say that to load R, as you saw on the loading and running, you need to also give the prerequisites. And you can find those with ML Spider R and ML Spider R / the version you are looking for. And then again, you start R, and then you run the same command as you did on UPPMAX, and you will then find what the path is on HPC2N. So as I said, UPPMAX had a lot of packages installed already, and so does HPC2N. And there are more than 750 packages now, more I think actually in the newer versions, that already come with the R module, and there's also the R bundle bioconductor module that you can load, which gives you even more packages. But you should be aware of one thing on HPC2N, which is there are only 2 versions of the R bundle bioconductor module, and that means you have to load a compatible R to use that. And it's R4.0.0 and R4.1.2. So you will have to use one of those if you're using this bioconductor module. And on UPPMAX, the R_packages module contains almost all packages from CRAN, and also the bioconductor ones are in that one. So there are lots of R modules, R packages and libraries available on UPPMAX and HPC2N. And you should check for that before you go ahead and try and install anything yourself. Let's see how you can check. So let's start R again. And then let's see if, for instance, dplyr is installed. And that it didn't find. So that is a good way of seeing if something is available or not. And I probably misspelled it. No, I didn't. Okay.
Did you misspell the library, maybe?
Yes, I did. Sorry. That was stupid. But in any way, it does not exist. So that is a good example of something that is not there. But otherwise, a huge number of packages is there, and you can go in, you can try and do this yourself. Load R, start up R, and then say library, and then the name of the library that you want. And you will find that most of them are actually there. dplyr is not, and that is actually one of the examples we're using later to let you try and install. So I'm having a bad day of spelling. Sorry. So this is the main way of checking. And you could also create a data frame for all the installed packages, but then you would have to filter it later. So there is one other way of doing things, and that is you can grep in the library directory. And grep is a command in Linux in the shell that is used to look for a specific string inside of, for instance, all the files in the directory or something, to see if one of them is named that. So we could try do that. And on bookmarks, let's see what we have here. We have, as you can see, we have R411 loaded. So let's also load the packages module for this. Okay. Well, let us see if the environment contains our lib site. It should, but I can grab from it. And there is indeed such a environment variable, as you can see here. So let us try and see if this actually works here. So what this line here does, it is saying I want to list this directory here that is, or this path that is included in the environment variable. And then I use pipe. And pipe means that I will now do a command on the output of what I got here. So I will do grep, and I will look for glmnet. And that gives you some outputs, and that is actually the packages that are with these, that has this inside of it, so this name. So that is also a very good way of finding if a library is there, if it's something you remember part of the name of. I will have to make a note for HPC2N, and that is, you cannot just use the rlib site for grepping in. And the reason for this is that on HPC2N, there are two paths, two directories that are in this environment variable. And that means that you need to use the command echo to show on the screen what is inside of it. And then afterwards, you grab the path that you want. And in this case, you would want the one that contains the R bundle. And then you do the same as you did at UPPMAX. Instead of the environment variable, you put in this path directly. I need to reload because it hadn't updated. So here, as you see, here is the path. And then we're grepping in it, and we're grepping for the letters RNA. And then you see which packages exist that has the RNA in it. letters in it, so that they will be about packages about RNA sequencing. So let's assume that you have done this. You have searched on the system. And this, by the way, you would do the exact same on many other HPC systems in Sweden. You have found this package is just not there. And what do you do then? You will have to check, you know it's there, you know it exists, so you can install it yourself. And often it will be a CRAN package, but as you saw above, most of the CRAN packages are actually already on UPPMAX, and many of them are also on HPC2N. But if there is one on CRAN that is not on our systems, then you could install it yourself. And to do this, you will need a place for the installed packages to be, and you need to tell R where that is. And that is important, because if you don't tell it, then it will not know to look in a different path. It will only look in the ones that are already set up for the system. So this setup should only be done once, but you need to create a package directory for each of the R versions used. So if you are sometimes using 4.0 and sometimes 4.1, then you need to create one for each of them. And R will look in the $home/.r environ file to set up its environment. But you should know that well, this is a file that's created by R first time you run it, but otherwise you can create it yourself. This command here. Touch just creates the file, you could say. It also would update the timestamp on it if it's a file that already exists, but you can use this to create a file. So let's assume that we place the R packages under your home directory, but in general, you will probably put it in the Brydsö because it can be quite big if you put a lot of packages in there. So you may want it there. And if you haven't installed any, then the environment file is empty and you can update it with this command here. So echo, as I said before, just outputs the content of something. And it can also throw it in. So if you are echoing a line, for instance, then it outputs that line. And in this case, you are sending it to this file, which would then be the R environ file in your home directory. And you should note that this %v, it should actually be there like that. You shouldn't change it. It will be substituted at runtime for the active R version. So it should be left like that. And when you have done this, you also need to create a directory that match this pattern that you made in the R environment file. And this here, home and slash your user, whatever it's called, this is the content of $home. So that means that you should create this in your home directory. If you instead had put it in the project directory, then you would have put that here instead. So we had this package. We are hoping it's on CRAN. And if it is, then on the command line, so here, you could type this here. After loading R, I should say, R needs to be loaded to do this. And this just sends this command to R that you want to install this R package. And you need to give a repo also, and you should pick one that is close to yourself. And repositories, repos, you can see those on this website here, and you should pick a close one to where you are living. and there will be some in Sweden. I believe there's one in Umeå actually. So if you are inside R, then you can run this command directly. You don't need to tell that it's to R because you're already in R. And again, you give the package name and which repository. And I will just click this link here to show you how it looks here. And this here is the CRAN page. And there's a lot of information here. And you have something down here, which is a list of CRAN mirror sites. So click this one here, and then you can scroll down and see is there something from Sweden. And there is actually one Swedish CRAN repository, and it's Academic Computing Club in Umeå University. So you can use that one. Or you could use one in Denmark or in Finland or something. Anything that's close. So because it will take a long time if you pick one that's further away. Okay. So here is an example of how it would look if you wanted to install Stringer package and using this repository just mentioned. And this is actually a good example that you could try and run. But, I can also try and do this. I am going to assume that it will tell me that it already exists. It is telling me that I forgot to set up my CRAN environment probably. Sorry, my R environment. Let's see, because I wiped everything I had just before the course, so I could redo it. It's still there. Let's see what's inside of it. There's nothing inside except that, which should be fine. Is this what you want? No, it's not, because I'm putting it in a different place. So I'm going to put it in this place here that we have for our storage, and then under my own space there. So I'm going to use that. And what I'm doing here is that I'm making sure that this file has actually been read again. I could also log out and log in. And let's then create a, well, let's see where I am. I am not in the right place. I will go to deploy, nice, 23, 22. I am in the right place. Yes. And I will create this directory. I wonder what version of R it was I used. 411. Okay. And now it should work. As you can see, if you hadn't created this directory yet for it to install in, it would attempt to install in the system-wide directory, which as a normal user you don't have access to. So it was a good thing I did not attempt this on Kebnekaise, because I would have admin rights there and thus have been able to install it to the system-wide package directory, and I didn't want to do that. So yeah. So you need to create this directory first.
And is it important that it is exactly that name?
It is important that it is called R minus packages minus the version of R. Yes, it is. Otherwise, it will not. Well, it's important that it's called what you put in your R environment file, because that is where it looks to see where it should put it. So whatever you write there is what you should call it.
Great.
So since I told it to call it that, I mean, I said that it would be called the path to my storage directory, and then R minus packages minus the version. So yes, then it has to be called that. And I will leave it to install here for a little while, but as you can see, it built a number of things. And now let's try start R, and then see if we can now load it. Yay, we could. So it succeeded. And this is an example that I think you should try and do yourself afterwards here, because that is a typical example of how you would do when you are installing a package yourself. So, and other options, maybe this package you're looking for is actually not on rcran. Most are, but there are some that will only be on GitHub. It's mostly if it's not yet in a state that is ready for rcran, for CRAN, yes. And if that is the case, you may find it on GitHub. Of course, that means that you should make really sure that you actually want to install this, because it might be a package that's not actually ready to use yet. But sure, there might be cases where you actually want a development version. For instance, it could be a project you are in developing something. And if you're installing it from GitHub, and then from inside R, you can install, for instance, the package like this. So you would need dev tools. This is something you would run just once, and then you can reuse it for all the ones that are installed this way. And then if you're telling it here, install underscore GitHub. And then this is what it would be called on GitHub. So it would be the developer's name and then usually the package. And here is an example of how to do this. So first, this was done just once, DevTools. And then you had some prerequisites, which would be listed on the GitHub page usually. So you just go ahead and install those. And then you install from GitHub, from the user BraveRock, these two R packages. And you can try that yourself if you want to. I'm not going to do that because I'm already out of time. And another option.
That DevTools is already installed on UPPMAX.
Okay, it's not on HPC2N, so there you need to install it. Or at least you did for R404. You may not need to for 411, but check. If it's a manual, you can do manual download and install also. And that means if you have the package as a tarball, then you can install it with R cmd install. So R command install -L, and then the path to where you put this package, and then the tarball. Don't unpack it, just install it as it is. And that means that, of course, it will not fix any dependencies for you, which it otherwise would for the other ways where you're installing it. You need to take care of those first. So check if it has dependencies, make sure you have installed that first. So what you do to repeat, and of course, before all this, you check if it's on the system you're working on. If it's not, check on CRAN. If it's not there, you can check RForge, you can check the project's own GitHub page, or maybe you heard about it some other way, but it would depend on the area you work in. And the key points of this is you can check for installed packages inside R with installed .packages and these two signs here. And if you're on the bash shell, you can also check if it is actually a module. And if it's something that within the R module, and you can do that by doing ML Spider R version on HPC2N or ML Help R version on UPPMAX. And that will actually list these packages. So let's try to do that. Let's see. It actually didn't. It has this, of course, it has changed because there are now so great many packages that you don't want to output all of them. It did that earlier, but now it just tells you that they exist. Let's try and do the same for the R packages. Which we also have loaded. And here it tells you that there is a lot of packages, and it's actually listing some of them and telling you where you can see the other ones. So in general, ML Show and ML Spider will give you information about a module on the system. And then very quickly, I will mention Bianca. Bianca is the system for sensitive data. And that is not done, things there are not done exactly like it is on the other systems. So if it's not already on Bianca in the Conda repositories, then you may have to use a program called WAF, or that is also something under R that you can use. And what you usually do if you want something to be on Bianca is that you install on Rackham, you transfer it to WAF, and you move the package to the local Bianca R package path. And then you can test your installation. And there is a link here to UPPMAX documentation pages where you can see a demo, and there's also an exercise for how you do that. And that comes from the Bianca course that is given by UPPMAX. And there is an exercise. And how are we on time? How badly are we on time? Can someone tell me that?
Yeah.
Because I
So-
believe I should have been done 15 minutes ago.
Yeah, it's up to me. Sorry for my first. But maybe we can jump this because it seems that most people have tried this during the code along.
Okay.
So my suggestion is that we continue.
Do you want to take a break, or do you want to move directly to the next area?
I think we can continue, and then we take a break approximately at 11 and see how far we have come.
Okay, in that case, I will move on to the isolated environment.